right, number 14. Why is this number not in scientific notation? Well, in order for it to be in scientific notation, our first factor, this base number here, the base number has to be greater than or equal to 1, but also less than 10. So 36.5 is greater than 10. Well, that's actually what you could put. 36.5 is actually greater than 10, and this number, this first factor, this base number needs to be less than 10. So you can only have one non-zero digit in front of the decimal point. Moving on to 15, write that in standard form. So we have 3.65 times 10 to the 5th. The exponent's positive, tells us that our base is getting bigger. We need to move the decimal point 5 times. 1, 2, 3, 4, 5. We need to plug in 3 zeros. So you need to rewrite this. It's 365,000. Moving on to 16. What power of 10 makes this statement true? So 78 billion is 7.8 times 10 to the, needs to go there, it's right here right now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to multiply by 10 to the power of 10. 17, write your answer in scientific notation. So we're adding here. So we always like to go to the bigger exponent, so we need to change this exponent to a 4. When we increase the exponent, this decimal needs to move so that we decrease this number. So we're going to write this with a power of 4, but in order to increase the exponent, we have to decrease our base number. So when we decrease this, we get 0.64 times 10 to the third. Then we're going to add 5.2, is that a 0, times 10 to the, actually no, this should be the 4th, sorry. So, now, when we add these, the 10 to a power is just like a denominator in a fraction. We'll keep that. Now we add the base numbers here. So we get 4, 6 plus 2 is 8, bring down the decimal, and we get 5. So we get 5.84 times 10 to the 4th. 18, round the population to 2 non-zero digits. So 10 millions place. And normally we get a lot of confusion on this problem, so we are rounding this 8. When we round this 8, we look at the 6. Does the 6 make the 8 go up or stay the same? It makes it go up. So this actually becomes 190 million. That's what we round it to. But we want to write it in scientific notation. So this number in scientific notation, our base number will be 1.9. Decimal right now is at the end. We need to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So we'll multiply by 10 to the 8th. So we get 1.9 times 10 to the 8th power. Number 19. change the length to scientific notation. So we have 0.12345. Then an 843. We're changing this to scientific notation. Our base number becomes 8.43, and every number in scientific notation is multiplied by a power of 10. We need to get the decimal over here. Our base number would need to decrease, so we'll have a negative exponent. It needs to move how many times? 1, 2, 3, 4, 5, 6 times. So 8.43 times 10 to the negative 6th. On to 20. Write the diameter in standard notation. So here we have 7.024 times 10 to the negative 5th. Negative tells us that our base is getting smaller. So negative tells us we're moving the decimal to the left 5 times. So 1, 2, 3, 4, 5. Throw in the zeros. So we get 0.1234. We have 4 zeros, then 7024. So at this point, guys, we can remember that when it's a negative, it's pretty simple to throw in zeros, because if it's correctly written in scientific notation, how many zeros are you going to need? Well, take here we have the number 5. I know it's negative, but let's ignore that for a second. We have the number 5. Take one away from that, it's 4. That's how many zeros there will be. But that only works as a rule when it is a negative exponent. Write a decimal between those two, then write the number in scientific notation. Okay. So number between 0.0006 and 0.0007. So a number could be 0.00065. Anything between that and that. And now we need to write that in scientific notation. Our base number would be 6.5. Every number in scientific notation is multiplied by a power of 10. We need to move it 1, 2, 3, 4 times, but our base gets smaller, so this needs to be a negative 4. 6.5 times 10 to the negative 4. All right, on to 22. Small organism with a length of 7.5 times 10 to the negative 6th meter, tripled in size. Write the new length in standard notation. This one is a little tricky because you're tripling it, so I was thinking that we would have to change this into standard notation, but we do not. So we're tripling this. So let's just multiply this by 3. We will hold off on that for a second. 3 times 5 is 15. 3 times 7 is 21, plus 1 is 22. Move the decimal over once. So what we're left with is 22.5 times 10 to the negative 6th. This is not in scientific notation. So we need to move the decimal once to the left, making that 2.25. What happened to our base? We decreased our base. When we decrease our base, our exponent needs to increase. Well, we decreased our base by moving the decimal 1 time to the left, So if we move it 1 time, we need to increase this by 1. So this is 2.25 times 10 to the negative